All right, deep breath. I can do this. All right, this is going to be a very exciting and riveting demonstration and explanation on how to solve the elucid inclined plane problem. Now, I haven't figured out all the quirks yet, so whenever I want to point to something specifically without moving it, I'm going to use Mr. Ducky. Okay, this is going to be my key pointer thing, so I don't have to necessarily use an arrow. So wherever the duck is, that's the key point to focus on. Now, we talked about the steps you want to take whenever solving any problem. So first one, you're going to read it. So one, I'm going to read this. Determine all the forces acting on the box, sliding down the ramp at constant velocity. My son would have loved that bouncing little ducky. All right, now, I'm going to then text mark what I saw. So key things that popped out to me. Let's see if I can get the red to work today. All right, we are sliding. All right, that means I'm going to have the force of friction, and since it is in motion, kinetic. So I know that's going to pop up somewhere. All right, another thing that's probably going to pop up somewhere. This says constant velocity. At this point in your brain, it should be screaming balanced forces. So that means that when I start doing a force diagram, they should all add to zero. Okay, a lot of tally marks. Next thing, it says all the forces, which means we're going to be doing some work here. All right, a lot of forces to be found. So I read it. I did my text marking. My ducky helped with that. Now I have to draw a force diagram. All right, so I'm going to redraw the picture. I like to draw my force diagram so that it's at an angle, just like the picture is. And here we go. Let's see. Gravity, last I checked, always pulls me down. Never had gravity help me up yet. Then I've got a normal force because right here, pushing up, ducky's pushing up on it. We got to have a normal force. It's going to be perpendicular to the surface. All right. Then, as we're sliding down the hill, friction has to work against us. And so that's kinetic. All right. So that's my force diagram. But ducky senses something evil. Force of gravity is not at a right angle. Whenever we do this stuff, we want everything to be in either the y plane or the x plane. Force of gravity is not in either. It's in both. So we got to do something with that. So I'm going to show you a cool little thing to show you how to kind of break that up, because what's going on there. Normally we'd use trig, which means we got to find a triangle. But what triangle do we use? What angle do we use? Okay, so check it out. So here we have a 30-degree angle right here in the bottom corner, and we got ourselves a triangle. All right? So what I'm going to do is I'm going to manipulate that triangle to show you how it relates to the force of gravity. All right? So here we go. Check this out. Click. First, I got to unlock you. You can now move. And then I'm going to clone you. Ha, ha, ha. And then I'm going to flip you. All right, haven't changed any scaling yet. Wait, do I want to do that? Yeah, sure, cool. All right, now I'm going to rotate you. Rotation. All right, and then I'm just going to kind of change the scale. All right, it doesn't change the angle or anything like that. It's just so I can fit it on the page. It's going to change the scale a bit. All right, now if I move it, I put it right where gravity would be. Look, it's the same triangle. Okay, it's the same triangle. Look, Ducky says that this is now perpendicular to the surface, and this is parallel to the surface. So really what we've done is we've broken up the original force of gravity. All right, so this is basically the force of gravity, the original one. But we don't want that because it's at an angle. It's ugly. It's hideous. What we really want, components. So if we look at the components, we now have the force of gravity that would be in our x direction, and we now have the force of gravity that would be in the y direction. And if you notice, we have the triangle, okay? It's a 30-degree triangle still, all right? Right angle here. It's the exact same triangle as this, just kind of tweaked around a bit. Thank you, geometry. All right? So we're going to use that to try and figure out what's going on. So I'm going to try and figure out how to do this using my friend Sohcahtoa. That's right, Sohcahtoa. So if I look at my triangle, this one right here, I want to figure out, well, how do I calculate f of gx and f of gy? All right, so let's go about that. First thing, f of g, let's do the y. Let's do the y, I like the y. So fgy seems to be adjacent, okay? Oh no, I drew on ducky. Oh my goodness. Oh, okay, safe. All right, looks to be adjacent to my 30 degrees, okay? Adjacent to my 30 degrees. So, adjacent has to do with cosine. So let's see, cosine of 30 degrees is equal to adjacent, which is the f of gy, over the hypotenuse, which is the original force of gravity. So now all I got to do is do some multiplication here. All right, so I'm going to bring f of g to both sides. So it looks like f of g, the y component, is equal to f of g cosine of 30 degrees. All right, it's the exact same angle that was in this bottom corner here. It's just right here now. All right. Ducky says hi, by the way. Okay. It's like, hello. All right. So I can now solve for that. That's kind of a good thing to know in the future. So I got some numbers because we were left with a few of those. So I know the mass is 10 and the angle is 30. And let's see, we're on Earth. We're on Earth. What does that tell me? What does Earth tell me? Oh, no, I've forgotten. What is it? Oh, yes. G is 9.8 newtons per kilogram. All right. So now I can actually solve this bad boy going down here. Well, oh, forgot Ducky. There you go. Ducky's coming with us. All right. So now I can actually solve this. So Fg of y equals, the mass was 10, field strength 9.8, cosine of 30, which, oh my gosh, I can do that in my calculator. Right now my brain is screaming, dude, didn't you pass the class where they made you memorize that stuff? Oh yeah, it's the square root of 3. All right, so when you crunch that all in your calculator, you get that Fg of y is equal to 113.16 newtons. That's good stuff. I mean, that's just exciting to know right there. All right, so I can take that number and I can go all the way back up here, all right, and I can actually write it into my force diagram here. So this is Fg of y, Fg of x. I have effectively replaced this. I'm like, I don't need you anymore. You're gone. Okay. All right, so I don't need that anymore, and I can replace it with a number. So Fg of y equals 113.16 newtons. All right, good to know. Good to know. Now I can go down a little farther. Look crazy. Look crazy. I'm going to go on the other side. I like to kind of break it up down the middle. All right. So Ducky's going to kind of jump the fence with us. Woo! All right. So now I'm going to look at what's happening in the x direction. All right. X right here. Let's see. How does that relate to our angle? It is across. It is across from the angle. Ducky says yes. So across has to do with that Sohcahtoa. So across has to do with sine. So that means I'm going to bust out my signage. So then we have Fg of x over f of g equals sine of 30 degrees. All right. Don't know why I didn't put the degree sign over here. Kind of creepy. All right. So now I can rearrange that a bit, and I can get Fg of x is equal to the original force of gravity times sine of 30 degrees. And then I can throw in the information I know, just like I did before. Well, let's see. Fg of x is equal to 10 times 9.8 times sine of 30. Right now, you should all be like, dude, I know what that is. That's 1/2. That's 1/2. So now, like, scream at the top here, I know that. So you got 49 newtons as your answer here. No calculator needed. If you did, seriously, go see a math teacher. They'll yell at you. Just like they yell at me. All right, so you got your two answers. Again, once we know that, we can take it back up top and we can do something with it. All right. What should we do? Ducky says we can now fill that part out. So we do. So this is equal to 49 newtons. All right? And then Ducky's screaming, "You forgot something! You forgot!" Okay, what'd I do? Oh yeah, that's right. I never marked to see what was balanced to remind myself that and that, that and that, because we have balanced forces. All right? So I right now have an awesome force diagram. I've filled in some information where I can. Now all we got to do is solve the problem. And to do that, we use our net force equations. All right? So I'm going to do some net forceage. All right? So net force, break it up again, just so I know where I'm at. Net force equation, I'll sum the forces in the y. They equal 0 because why? We're balanced. So if I look in the y direction, all right, up here with Ducky, Ducky says, "Dude, you only got two forces. You got the normal, positive, and you got the y component, which is negative." All right, so let's take Ducky on a trip. Oh no, what am I doing? Oh no, oh, horribleness. Did I lose Ducky? Oh, phew, saved him. Oh, that could have been traumatic. He'd been like, "I am lost in a triangle. Help me." All right, so we got to bring Ducky down with us. All right, don't want him to feel lonely. So now we put in those forces we know. We said that the normal force, that's going to be positive. All right, minus force of gravity in the y direction, well, that's going to equal 0. Force of gravity in the y, we can do some replacement here and do some math. 113.16 newtons equals 0. I think Ducky knows the answer. What is it, Ducky? What is it? Was it? Yes, you're right. He did that without his calculator too. Can you? I don't know. Can you do that with your calculator? Can you beat a duck? All right, so we got the y, so we now know the normal force. So if we really want, and we could go back up here just so we can like cross stuff off the list and say the normal force, hey, you're 113.16, congratulations, go find yourself a cookie. The only one left is this force of friction, and it is in the x-plane. All right, it's in the x-plane, so we can go down here. That means we need a net force equation for the x's. I think we need more pageage. That's right. All right. So now if we look in the x, sum of the forces in the x, again equaling 0 because everything's balanced, we had, I'll use it because it's here, the force of gravity in the x that was pulling us down, force of friction, kinetic, was hating us, slowing us down. So then we got equaling 0 because they're all balanced. Fg of x, let's see, what was that? Oh no, I drew on the page. 49. So we have 49 minus the force of kinetic friction equaling 0. Oh, Ducky, what's the answer? It's this one. All right, so Ducky knew the answer. I had totally forgotten. So force of friction kinetic is equal to 49 newtons. All right, so again, if I really wanted to, I could go all the way back to the top to just fill that in. Just so I know. This is just for me. All right, 49 newtons. So that's how you solve an inclined plane problem. It's basically exactly the same as every other type of problem. The only big difference is that basically this cosine right here. Wait, where's Ducky? I lost Ducky. There he is. Okay, right here. Is it cosine is usually associated with the x, but here obviously it's the y. And sine is usually associated with the y, but here as you can see it's the x. All right, so that's the big difference. You're basically just flipping what's normally associated with each other, and that's based totally off of the geometry of this picture. So that's how you solve an inclined plane problem. I hope you had fun. Say bye-bye, Ducky. All right, Ducky.